Okay. So let's get back to what we were talking about. What were we talking about? What's your name, please?
Oh, Lisa?
Nope. You?
Amy?
Nope. In front of Amy?
Me?
Yes.
Vivi.
Vivi. Okay.
Yes.
Sorry.
Yeah.
Okay. So what were we talking about? Anybody remind me what we were talking about? Absolute value. Okay. So yeah. So we were talking about what is the absolute value, right? So absolute value. Right? Absolute value, really you want to think of this as a function, absolute value function. So right, it's a function, it's this thing, there's like a space in the middle for you to put numbers in, and then when you put something inside of it, it gives you some value, right? It evaluates to something, right? And does anybody remember the definition of this? What's the absolute value of x?
Just show the difference from x to 0.
Okay, so you can say the geometric definition we had was the distance from x to 0. Okay, and then there was an algebraic definition. Janie?
X if x is greater than or equal to 0, and negative x if x is less than or equal.
Right. Okay, so this was the algebraic definition. It's good to know the geometric way of thinking about it, but you have to know the algebraic way. Okay, you have to know this. So please know this. This is basically our first real definition. And remember, at the beginning of the course, I said mathematics is sort of the study of these things that are constructed via definitions. Here's your first real definition. Okay, so for example, right? I think one of the things we finished off with last time was if x is less than 0, what is the absolute value of negative x? Okay, the absolute value of negative x. I think for a lot of people, your instinct, often you don't, in elementary school, or not elementary school, in K through 12 education, you don't think of the absolute value in this definition way, but rather you think, I have to get rid of the negative sign, right? And so you've got this like sort of like concrete way of thinking about the absolute value. You just take off the negative signs. That's all you do. That's all you do. But you notice that's not the definition. We don't use that as the definition, right? And there's a reason why it's not the right way to think about it, right? Because if I say, oh, I just take off the negative sign, well, then this would be the answer, right? Right? So, but that gives me a negative number, right? X was a negative number. Remember, so x, well, if x is negative, right? If you start off with a negative number, what's the absolute value of negative that number? Well, it's not. You can't just pull off the negative sign, right? You have to go back to the definition and say, okay, well, the definition says it'll be the input, right? If x is positive, the function will return the input. If x is negative, the function will return -1 times that input. Okay, so here I come to here, and you need to think, well, what is this? This is right. I think, well, negative x, x is less than 0, so negative x is greater than 0. So this is positive, right? So I come over here. I say, okay, the input is positive, so the output will just be that thing. Okay. So you want to. This maybe is like I don't know, like your first step into more abstract thinking rather than concrete thinking. Okay. So like in your childhood, you have this like, oh yeah, I've got sort of these rules, like, okay, get rid of the negative signs. Get rid of the negative sign, but that's actually not the definition here. You have to think, in mathematics, you have to think about definitions. So here we come back to the definition, we say, okay, well, what does the definition say? It says, return, if this thing is positive, return that thing itself. Okay. Right. Right. And similarly, if I said, what's the absolute value of x? What's the absolute value of x in this case? X is negative. What's the absolute value of x? Write something down. Take 10 seconds to write something down. Okay, turn to somebody nearby and say, this is what I wrote and why. Talk with somebody nearby. Okay, would somebody like to tell me what I should write here? What is it? What is it? So
It would be negative x.
negative x, right? Maybe it's gonna be negative x. Why? Because what's the definition, right? This number is negative already, so right. So the absolute value of it will be negative it, right? So go back to the definition. The number was negative, right? The input here was negative. So the function says, oh, you handed me a negative number. I have to give you -1 times that number, right? Which will be positive, right? Which is good because the absolute value should return a positive number, right? So, you know, try to get. It's good to have some sort of instinct about this, like what the absolute value is, but also it's very important to know what it is actually, right? What the absolute value is, right? It's this creature that says, if you give me something positive, I'll hand it right back. If you give me something negative, I'll multiply by -1 and give it back to you positive. Okay? It's like, you know, like a very advanced human being. Right? Whatever you give to me negative, I'm going to make it positive and give it right back to you. Okay. 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 Is that making sense to people? Anybody?
I feel like I don't quite understand.
Uh-huh,
Like you
okay.
said, multiply by -1 at a certain, like, a certain point, and I think
So it's going to, this negative x is same thing as -1 times x, right? So, you know, if you give it something negative, it's going to take it and multiply it by -1 and then return it to you, right? This is what you know. You actually know this, right? If you take the absolute value of -5, what does it do? It multiplies it by -1 and then returns it to you, right? So it gives you back -5, which is 5. Okay. So I think the difference is that people are thinking about like stripping off the negative signs, right? If it's negative, strip off the negative signs, right? But I think the better way of thinking about it is if it's negative, you multiply it by -1. Okay, so like here you've got this negative number, so you've got this negative number, so you give back -1 times it, right? Here you've got a positive number, so you just return it. Okay, don't think about stripping off signs. That's the wrong way to think about the absolute value, right? Because if you strip off the sign here, you're going to get a negative number, right? Okay. That's not what the absolute value does. It says, if it's positive, I return it. If it's negative, I multiply you by -1. Yes, please.
I'm just confused because it's like the absolute value of negative x is negative x, and then the absolute value of x is also negative x. So wouldn't the first one, would you just put x? Because it's already known that it's negative.
Oh, I'm sorry. This is x,
Yeah.
right? Oh my God. Yeah. This should be. This is wait.
Wait, no, it's
No,
not.
no, no. This is negative x, and this is x is negative. So the absolute value of negative x is negative x, right? right? Right, x is negative, negative x is positive, so you just return it, right? Here, x is negative. No, that's right. That's right. Both of them are going to be because this was all right. Sorry. Well, both of these things are going to be negative x because negative x is positive.
But if you put just x, wouldn't it just, we know that it was negative 2, because we already know that it's less than?
I'm sorry.
Couldn't you just put also just x?
No, because x is a negative number.
So the negative sign makes it positive, is that what you're saying?
Yeah, the negative sign gives you a positive number, right? Not good.
If we have like x and it's negative 2, so we're doing negative and then parentheses negative 2, and then that makes it positive. which makes it positive. It's just the notation's a little confusing.
Thank you, Amelia. Let me make this concrete. So suppose we have x, it's negative 2, okay? What's the absolute value of negative 2? Right? Well, it's negative 2, right? Right? Down here, what's the absolute value of negative 2? Well, it's negative 2 again. They're both going to be this positive number 2, right? So you get negative x here, you get negative x here, right? All this is saying is that the absolute value of, if you have this guy is 2 and this guy is negative 2, they both have an absolute value of 2. Okay, don't worry, everything is strange when you first see it. Okay, but you have to make this step into, like, the definition world. Okay, so just think, right? If x is negative, negative x is positive. So the absolute value of the positive number is just that number, right? Is that clear? Okay. If x is negative, then the absolute value of x is negative that number. So absolute value of this negative number is negative that number. Okay, that's okay, right? Okay, so just remember the definition, and remember that the definition is the real thing. Okay, not the idea of just pulling off the negative signs. Because pulling off the negative signs works if you're working only with numbers. Okay, but we're not going to work only with numbers. We have variables, right? And in that case, things become a little bit. You have to be more careful. Okay, so this is just sort of a warning. Like, we have to be a bit more careful from here on in. Okay, let me go on. So there are some properties of the absolute value that they just state. Okay. So the first one. So there's a bunch of properties that they state. The first one is that the absolute value of something is always greater than or equal to 0. Okay. These are things that probably you find pretty evident. Right? So remember, the absolute value of something is going to be that something if x is positive, and it's going to be negative with something if x is negative. Right? So you can see that the absolute value is always going to be a positive number, right? Because it returns, if it's positive, it's positive. If it's negative, it's going to be negative that negative, which is positive. So absolute value is always a positive number. Second thing is that the absolute value of x is always bigger than or equal to x. Okay. It's always on the right side of it's either equal to or to the right of x itself. Right? And you can probably convince yourself. You can probably convince yourself of that graphically, right? So like, if this is, say, suppose this is x, suppose you have some number 5, you have some number -5, right? The absolute value of 5 is always bigger than or equal to 5, right? The absolute value of 5, the absolute value is going to be the one on the right, right? If you have 5, if you have some number and it's negative, the absolute value is going to be the positive one of this, right? So, so you know that it's going to be bigger than or equal to the number itself. It's also going to be bigger than or equal to the negative of that number. Okay. Is that okay? Does that make sense to you guys? I think I'm not going to try and go back. You can show all these things using the definition, but I think I don't want to do that at this point. It's just gonna make things worse. So so I'm not gonna do it, but I could. We could. Yeah. Okay. Another property they have is related to multiplication. So I should say that why do we care about this? Why do we care that the absolute value is always bigger? Sometimes in math, you have to get control of the size of something. Okay, so you're like, I want to make, is this thing bigger than that thing? Okay, and so you need, sometimes you use this sort of thing. This way will be involved in something that we'll call bounding. That is getting a max on the size of something. Like say, okay, I've got all these values, but they're all, I can do this calculation and they're all less than 5 or something like that. So I'm gonna say, I know that all these things are less than 5. So in math, sometimes you need to create what's called an upper bound or sometimes a lower bound. Okay. So that's why we care about this, right? That the absolute value of this is always bigger than x. It's also bigger than negative x. Another property is how the absolute value works with multiplication. The absolute value of a product is equal to, does anybody know? Absolute value of a product is, yes, for
The absolute value of A times epsilon.
yeah, it's a product of the absolute values. You can probably convince yourself of that, right? With some examples. That's not a proof, but I'm just going to leave these as facts. Okay. And then 2b is something how the absolute value works with addition. A plus b is always less than or equal to the absolute value of a plus the absolute value of b. Okay. So this is something called the triangle inequality. The triangle inequality. That the absolute value of a sum is always controlled by the sum of always smaller than or equal to the sum of the absolute values. So if I write this first one in English, it's the absolute value of a product equals the product of the absolute values. Right? And then this one is the absolute value of a sum is smaller than the sum of the absolute values, if you want to write it in English. Okay, let me do some examples to illustrate these things. Okay, so for, if I'm thinking about 2a, the absolute value of negative x, I can write as the absolute value of negative 1 times x. Right? So that's by using 2a I see that's the absolute value of -1 times the absolute value of x. And the absolute value of the product is the product of the absolute values, right? And so I get, the negative absolute value of -1 is 1, and so I get x, absolute value of x here. So the absolute value of negative x and the absolute value of x are the same thing, right? As you knew already, but it follows from this product, from this property. Right, sort of along the same lines, if I have the absolute value of -2 minus x squared, then I can pull out a -1, right? I can say, okay, I can just say that this is the absolute value of 2 plus x squared, right? Everybody see that? Because I'm just factoring out, this is going to be -1 times 2 plus x squared, right? And so I get the absolute value of -1 times the absolute value of 2 plus x squared, right? But this thing turns into 1, so I'm just left with this. Okay. So you can pull out constants, right? Like if I've got -5 times x plus 3, right? So I've got -5 times x plus 3, but that's just going to be 5 times the absolute value of x plus 3. Is that sort of thing clear? So this property will be useful to you mainly to pull out constants, or to break something into factors. Right? Like if I have x minus 3 times x minus 5, that's the same thing as the absolute value of x minus 3 times the absolute value of x minus 5. So you can break products up into, you can break the absolute value of the product into the product of the absolute values. Let me go on. Okay, so those are some properties of the absolute value. Here's something really useful. So useful interpretation. Of the absolute value, and that's its relation to distance. So, so observe that if you take two numbers, x minus y, and you take two numbers, x and y, and you take their difference, right? So here's x, let's say, here's x and here's y. Okay, then if you take the bigger guy minus the smaller guy, then that's the distance between them, right? If you take the smaller guy minus the bigger guy, you get kind of a signed distance. You get -1 times the distance, right? That makes sense? Like if this is, sorry. So if I have x and y here like this, right? If I take y minus x, I'm going to get a negative number, right? So x minus y is the distance. Y minus x is negative the distance, right? Well, if you take the absolute value of that, if you take the absolute value, then you just get the distance. Right? You get rid of that sign. You get a positive number, and you get that positive distance. Okay. So no matter what two numbers you have, like if I have 3 and 5, well, the absolute value of 5 minus 3 is 2, which is the distance between these two numbers. The absolute value of 3 minus 5 is 2, also 2, which is the distance between these two numbers. Okay. So this thing is the distance between x and y. Okay. And it doesn't matter which one is bigger or smaller. If you do it in the wrong order, the absolute value is still going to give you the right answer. So this is a very useful way of thinking about the absolute value. Right. That's one example. For a second, more complicated example, suppose I have 3 and 5 like this. The absolute value of -3 minus 5 is 8, right? Which is the distance between these two guys, right? And the absolute value of 5 minus 3 is also 8. So you see, this works for negative numbers, combinations. Right. So, what's the point here? The point with this the reason I introduced the second example is because if you see something like the absolute value of x, if you see something like the absolute value of x minus y, well, that's just the distance between x and y. Right. If you see something like the absolute value of x plus y, you can still recognize that as a distance, right? That's going to be x minus y, right? So that's the distance between x and minus y. Right. That's the point of that second example. So if we go back to intervals, this gives us a kind of nice way of describing intervals. So I'll just sort of introduce it by example. So if I say, like, what is the set of numbers for which the absolute value of x minus 2 is less than 1? Okay. So you could work this out with the definition, but a much easier way is to think about this to interpret it in terms of distance. Okay. So what is this if I translate into distance language, what's this thing on the left here? The absolute value of x minus 2. Well, that's, in terms of distance, remember, the absolute value of x minus y equals the distance between x and y. So this is just going to be the distance between x and 2, right? So what is this thing? It's the set of x for which the distance to 2 is less than 1, right? The distance of x to 2 is less than 1, right? So on the number line, here is 1, and I'm sorry, here is 2, and this, what set is this? It's a set of x's whose distance to 2 is less than 1. So it's everything between 1 and 3, right? Everything between 1 and 3, right? Everything whose distance from 2 is less than 1, right? So that's, 1 and 3 are kind of the boundaries. Okay. Let me give a couple more examples. Suppose I have, like, x minus 2 is less than or equal to 1. I'm not going to write the full thing out. What would that be? What interval would that represent? Take 10 seconds and draw something. 1 minute and see if you can draw these 3 intervals. Actually, the last one is not an interval, but draw these 3 sets on a number line. Okay, turn to somebody nearby and say, this is what I drew, this is what I got. Okay, in the interest of time, I'm just going to write down the answers here. So here this says, I'm looking at the x's whose distance from 2 is less than or equal to 1. So if this is 2, then, and this is 1 and 3, then it's going to be everything whose distance is, everything between 1 and 3 inclusive, right? So you're allowed to, the distance is allowed to equal 1 in this case. So you include 1 and 3. Whereas in this one you didn't, because it was less than 1. Now the second one, I have to rewrite a little bit or rethink it, right? It's x plus 3. If I want to think of this as a distance, I have to say this is x minus 3, right? So I have the minus 3 back here, right? I've got a minus 3 back here, and the distance, everything whose distance from minus 3 is less than 2, right? So I'm going to step 2 steps away, 2 steps away. The distance has to be less than 2, so I don't include those points, and it's this set, right? It's this interval. The last one, it is everything. So again, this is x minus 3. So you say, okay, this is all x's whose distance from minus 3 is greater than or equal to 2, right? So again, step 2 away. So I want, it's allowed to be 2. Right? These guys are 2, distance 2 away, and everything whose distance is greater than that, right? So this and this, right? If I wrote these things as sets, right, this would be 1. If I wrote these things as intervals, this would be 1, 3, closed set. This would be -5, -1, open set. And this one would be -∞, -5, inclusive, union, -1, I'm sorry, yes, -1, positive infinity, positive infinity factors. Okay, so this is the union mark, meaning this set and this set. Okay, sorry to make you guys late. I've run over. Stop here. On Friday, we're going to go through 1.3 equations. That's it. You can go.